Hey guys, Mr. Crowther here. Starting with the intro to graphing linear equalities. Building right off Mr. Prue's review video on graphing lines. We're going to take this to the next level with linear inequalities. So the first thing we need to kind of recognize is the difference between an equation and an inequality. So if you remember back from Algebra 1, inequality has these symbols: greater than or equal to, less than or equal to, greater than or less than. And these are going to affect your graph in the following ways. Whenever you see a greater than or equal to or less than or equal to symbol, your graph is going to contain a solid line. And whenever you just see the less than or greater than symbol, your graph is going to contain a dashed line. And because these are inequalities, these lines are called the boundary lines. So when we have greater than or equal to or less than or equal to, points that are on the solid line are part of the solution set. If we have greater than or less than, points on the dashed line are not part of the solution set. That's a big difference. So these lines represent the boundary lines as we're going to create an area of solutions on a coordinate plane. And the solid line is included in those solutions. The dashed line is not. And it's all based upon the inequality symbol that we are graphing. So I talked about that area of solutions, and this is where the major difference between a linear equation and a linear inequality lies, and that is shading. So whenever I'm graphing a linear inequality, so hypothetically, let's say I have my solid line like this. That would be a linear equation. A linear inequality will have shading either below, indicating that all the points below the line are also part of the solution. The other option would be to shade above, indicating that all the points above the line are part of the solution. So again, two major differences will be determining whether it's a solid line or a dashed line based on the inequality symbol, and then which part of the line to shade, either above or below. And we'll get into how we're going to look at that. So I have a couple examples we're going to go through. So the first one, we're looking at the equation y is less than or equal to 4/3 x minus 4. So the first thing I want to look at is this less than or equal to symbol. Because it's or equal to means I'm going to have a solid line. And I'm going to graph these just as I would graph any equation. So one way to do it, my y-intercept is at -4. The 4/3 of my directions to get to the next point. If you remember rise over run from the last video, change in y over change in x, vertical over horizontal. I'm going to go up 4, right 3, because both are positive, to get to my second point. And I'm going to have a solid line there. So that's the first part. The second part, my y values are less than this line. So my y values are going to be below this line because it is less than or equal to. So where my y values are lower than the line, given this is my y-axis, my lower y values are going to be in that direction. So for shading, I'm going to want to make sure that I shade in everything below the line. And that is a graphed linear inequality. What does that mean? So that means that any point in the shaded area or on the boundary line will be a solution to this inequality. So just to show you, we will take the point 4, -2. That is definitely in the shaded area. So for an x value of 4 and a y value of -2, I'm going to replace x and y with that ordered pair. Again, 4, -2. I end up with -2 is less than or equal to 4/3. 16/3 minus 12/3. And that is a true statement. So I know I have shaded in the correct location. The other way to look at it is to pick a point not in the shaded area. And the point I always check is 0, 0. And if that is a true statement, then I should shade there. If it is a false statement, I should not be shading there. So here I have 0 is less than or equal to 4/3 times 0 minus 4. 0 times anything is 0, so I have 0 is less than or equal to -4. That is not true. 0 is greater than -4. So I should not be shaded in that area. That should not be part of my solution set, which is great because the purple area and the black boundary line are part of my solution set. So what happens if we have just one variable? If you remember back, if I just have a y is greater than -4, that is going to be a horizontal line. So again, greater than or equal to means a solid line. It's going to be a horizontal through +4. And I want the y values that are greater than 4, so they will be in this direction. So I will shade everything above here. Now this one's an easy one to check. If y is 6, 6 is greater than or equal to 4, it is in my solution set. If y is 4, that is on my line, 4 is greater than or equal to 4, so that is part of my solution set. And I can always check 0, 0 down here. That is not in the shaded area. 0 is not greater than or equal to 4, so it should not be in my shaded area. So I've shaded in the right direction. So for those of you who are watching the video all the way through, this is the verification phrase for the exit ticket. Based on the documentary that's out right now, The Last Dance. That's what you're going to put into your exit ticket to verify that you have watched the introductory video. So what happens if we have that greater than symbol without the greater than or equal to? So greater than symbol by itself, some snazzy drawing, means a dashed line. So again, I'm going to graph it as I would any other define the 2 points. So my y-intercept's at -5. I'm going to go up to right 1 because I got to think of this as 2 over 1. And instead of a solid line connecting them, I'm going to have a dashed line connecting them. And we'll check out why in a second. y is greater than this line. So the values of y that are going to be bigger are going to be in that direction. So I'm going to want to shade all of this area over here to indicate my solution set. So I'll go right back to the easiest point to check, which is going to be 0, 0. So as long as your line doesn't go through 0, 0, it's a great point to check. So 0 is greater than 2 times 0 minus 5. 2 times 0 is 0. 0 minus 5 is negative 5. 0 is greater than negative 5, so that is a solution and should be in my shaded area. Looking at my graph, 0, 0 is in the purple shaded area. It means I have shaded in the correct direction. Let's check out this dashed line. We know down here, 0, negative 5 is a point that is on that line. So if I put that into my equation, negative 5, I end up with negative 5 is greater than negative 5. This is not a true statement because there is no or equal to. A negative 5 is not greater than itself. So this indicates that my line is dashed so that the points on the boundary line are not part of the solution set. So if we think in terms of infinitesimal decimals, as we get closer and closer to that boundary line in the shaded area, I'm going to be solutions, but as soon as I hit that boundary line, I'm no longer a solution. Let's take a look at one more example. So this one I wanted to put it up because it's not in our traditional y equals mx plus b form. So we have a couple options. The first option is to convert it into that traditional form. So I would subtract x from both sides. And to get y positive, I'm going to multiply both sides by negative 1. Now, if you remember back to Algebra 1, whenever you multiply or divide both sides by a negative, I need to reverse the sign. That is a key point in the inequalities that you don't see in the equations. So y is now less than x minus 2, because I have to distribute that negative 1 to both terms in parentheses. So I can graph that by starting at negative 2. My slope is 1, so I'm going to go up 1, right 1. It is less than, so I'm going to have a dashed line. Because y is lower than that line, less than that line, I'm going to be shading in the downward direction, so I'm going to be shading below the line. So now I can check a point. Again, 0, 0 looks great. 0 minus 0 is greater than 2. 0 greater than 2. 0 is not greater than 2. So it should not be in my shaded area. It's not. So I have graphed the correct shaded area below the line. Now, if you struggle with the algebraic process of manipulating the inequality by moving things over, the other option is always just to create a table. And for me, the easiest table to create is the intercepts. So when x is 0 and when y is 0. to get my 2 points. So I put 0 in for x. I'm 0 minus y is just negative y. Multiply both sides by -1. Y is greater than -2, so I'll have 0, -2. And if I put 0 in for y, I end up with +2. So +2, 0, those are the 2 points that I can draw my line on. So we'll mark them in black. So 0, -2, we already have on the line. And 2, 0 is also on the line. So that is the second method. It's just to find those intercept points by putting in 0 in for x and 0 in for y to find your 2 points so you can create your boundary line. So that is how we graph linear inequalities. Again, greater than or equal to, less than or equal to, solid line, greater than or less than, dashed line. And the key difference is the shading. Less than or equal to or less than, I'm going to shade below the line. Greater than or equal to, greater than, I'm going to shade above the line. So we have a couple practice things for you and an exit ticket. And we are hitting the home stretch, so I hope everybody's doing okay. Feel free to check in with any of your teachers at any point this week to make sure that we are staying on track through the final 5 weeks of the year.